Well, I want to start off by saying thank you for sneaking my dust talk in between all the ozone talks. Yep. So my research is focused on looking at mostly dust storms, but a few other exceptional events that may occur along the Wasatch Front, and looking forward at what those events do to the air quality here in the valley and also potentially water quality in the snowpack. So first things first, dust storms, exceptional events that happen here out in the great deserts of the Great Basin. You can see here in the picture, right in the middle of the Dugway Proving Grounds, there's a nice little dust plume getting picked up, getting shipped off to the northeast over the Great Salt Lake. And dust storms are not unique to just the Dugway Proving Grounds. They happen at every single playa in the Great Basin. And along with those natural sources, we also have urban sources such as gravel pits and oil refineries and other fugitive dusts that contribute to the air quality here in the valley. And then there's multiple ways for the dust to be transported. It can be deposited as your classic dust storm, that dry event, but it can also be transported in snow or rain. And this right here is the aftermath of a snowstorm that happened in February last year. And you can see there's quite substantial dust deposition just from that one snowstorm. And then the reason why we're looking at this is to, of course, take inventory on the human health impacts. The dust transported to the snowpack will affect the longevity of the snowpack as well as the quality of the water running off that we use here in the valley. And then in addition to those dust storms, we have other exceptional events that happen here. We have winter inversions, of course, which have been talked about, wildfire, smoke, and then fireworks. Fireworks actually make it a little bit difficult to track dust storms based on the way that we're tracking them. So it's important to know when those happen. Where this is all happening is basically, think of ancestral Lake Bonneville. Anywhere that used to be, that's where the dust is coming from. Two places of note are Severe Dry Lake southwest of Delta, Utah, and then the Great Salt Lake lake bed. This is exactly, if you look at that map, that's another outdated picture of the Great Salt Lake greatest extent. It's a little bit drier than that now. And so all of that newly exposed lake bed is a breeding ground for dust. And the way that we're tracking this dust from those sources is we're using strontium isotope ratios. These two different areas have unique isotopic ratios. Severe Dry Lake is about 710 and Great Salt Lake lake bed is about 715. And those two areas serve as end members, so to speak, of where we would expect dust here collected in Utah or in Provo to look like. So those are the two end members, and all the other playas fall somewhere in between. So we're using those as our end members. So just across the sidewalk over the Iron Science building, we have 3 different filters collecting constantly, going 24 hours a day, 52 weeks a year. And we're collecting dust on those filters every 2 weeks at the PM 2.5, PM 10, and TSP size fraction. And as well, along with that, we're also collecting wet and dry dust deposition in that little yellow bucket in the back. There's marbles on top and a screen below that, so water and snow fall in between, and the dry dust will collect on those marbles, which will rinse down and collect in the tote below. And then we also did a bit of urban hotspot sampling. We went around to different gravel mines, gravel quarries, to see if we can identify what that dust would look like, that urban source would look like compared to our natural dust source of the Great Salt Lake and Severe Dry Lake. And then we went up into the Uintas and collected a few snow horizons to see what the dust looks like that actually gets transported into the snowpack. We analyzed that, of course, for 44 major and trace elements, as well as the strontium isotope ratios. So the first result, or the first trend that was noticed in the data was winter inversions. Here we have arsenic, iron, thallium, lead, and cadmium all collected here in Provo. And I should note that this is actually part of the first step of an acid leach process. It's the acetic acid, and this represents the water-soluble and bioavailable element fractions. And so this is what would get transported into our water supplies and get taken up by plants. But moving forward, looking at more of the human health side, this is the total concentration of these elements aside from all leach steps. And we notice that particularly lead, which is the only element currently on the EPA's air quality guidelines, it falls well below that guideline of 15 micrograms over a 3-day period. And this is taken in nanograms per meters cubed. The next trend that we noticed was fireworks. Barium, potassium, and sodium all play an important role in making those colors for the fireworks. And I don't know if you can pick out those particular holidays, but we have, let's see, 4th of July, New Year's, 4th of July again. It's very interesting to see that it's picked up so readily just from a few hours worth of fireworks. And finally, the most important one that we've been focusing on was dust. While it may not look like much, this data actually shows is in line with what we already know about dust transportation, is that most of the dust is transported as either the PM 2.5 or the TSP size fraction, not so much the PM 2.5. And looking again more towards the human health side of it, we see that trend again. And you'll notice there are 4 different dates on all of these elements that are above the average, so to speak. And those all fall on dust event days that we've noted back in 2020, 2021. And then, of course, things can't all be simple. So we have a few mixed signals. The first is strontium. It's a mixed signal between fireworks and dust events, which makes it complicated for tracking dust because we use strontium isotope ratios to track our dust storms to see where they're coming from. And then the other one is a mixture between fireworks and other anthropogenic sources. And we see a slight trend in winter inversions at those peaks, which then gets overridden by fireworks. And looking at the strontium isotope ratios over the last 2 years, we can see that a lot of these measured results fall below our theoretical minimum of 710. And that causes some problems for tracking dust. If you expect all of our values for dust to be between 715 and 710, then why are we getting values below our minimum? Well, that's because we're picking up more than just dust. As you can see in green, we're picking up fireworks, which represents our yearly minimums for strontium isotope ratios. We're also picking up fire smoke, which likely represents dust picked up from updrafts from wherever the fire is burning, which represents the dust or soil in that region. And then finally, looking at what we're concerned about, the dust events. All of those days with dust events fall right around 710 and in between. And there's these blue diamonds that don't have a label. Those are snow horizons that we collected up in the Uintas. And so these 2 blue diamonds that are right on top of each other, those are both from the same snowstorm, but collected at 2 different areas. This lower one was collected up in Mirror Lake in the Uintas around Mirror Lake. And this other upper one was collected at Alta Ski Resort up near Snowbird. And so the dust for that storm likely comes from different sources. With the Uinta dust is coming from severe dry lake, whereas the Alta dust is coming mostly from, or a mixture of Great Salt Lake and severe dry lake. And so it's important to keep looking at this because as the Great Salt Lake recedes or continues to recede, it's creating more of a breeding ground for this dust. And so it's important to know what's getting picked up, where is it getting transported, and how is that going to affect the human health and water quality and air quality too. So thank you. Any questions?
So what's the source of the strontium? Is that left over from the nuclear tests?
No, so strontium commonly replaces calcium in the carbonate structures and playa beds. So we have our standard calcite, calcium carbonate. Strontium will replace that. Oh, the source is the rocks around the playa beds, weathering from that. Oh yeah.
Yeah, I'm wondering if I think you could feed your data set in to do some positive matrix factorization or something like that on it, because it seems like a great candidate where you have distinct sources, you could separate out isotopes, and then possibly still get a dust signal that's independent of the fireworks and the others.
Yeah, that's actually what I'm in the middle of working on right now. And then I've also done a principal component analysis on it, but that wasn't too enlightening since neodymium was by far the most influential factor. Yeah. Okay.
Change over everything.
Oh.
Okay.
Okay.
Do you know if there's any like mitigation measures in place or like the sources of dust?
I do not. The only thing I know about is state legislators about a month ago did a helicopter sightseeing tour of Great Salt Lake, but I haven't heard anything come of that.
We have time for a short question, John. Okay.
So the dust events look like they were mostly from the severe in the last slides. Yeah, this one. The dark
Yeah.
blue is it? So does that mean the Great Salt Lake isn't contributing very much?
So that's something that I guess I don't really have time to explain. Is Provo and Salt Lake City kind of have two different dust sources because of the way the mountains lie and the dominant wind direction. So let me go back to this first picture really quick, sorry. You'll see the snow plume or the dust plume and the clouds show a lineation towards the northeast. That kind of dictates where the dust comes from. So here in Provo, we're south and east from the Great Salt Lake, so we don't really see that. But samples got taken from the DAQ from 2008 to 2009 show strong influence of Great Salt Lake for Salt Lake City.